Dear world, welcome back to the LeetCode 103 Zigzag problem. So in today's video, what it tells that we have to traverse the route in zigzag fashion, that is from left to right, like this. It's binary tree zigzag level water traversal. So here it tells that first we have to traverse from left to right. That means first we'll be traversing like this, from left to right, this side. And then in the next we'll be traversing the same things from right to left. That means in the next pattern, when second time, then we'll be inserting like this from right to left. So this time we'll be inserting from right to left, and first time we'll be inserting from left to right. So that is the zigzag fashion that we have to mention. So this is similar question that like level one the traversal I made you understand, but there's a little concept different. So let's understand that how we can solve this problem. So first what we need to do while level water traversal, that first whenever solving question on LeetCode, first we have to create the tree. First number of things that will be creating this tree. So inside main function we'll be creating that tree once the tree is created, and before that we have to declare the root node also in the main tree. So okay, that is done. Once that is created, now we have to utilize a kiwi for level water traversal. When it comes to level water traversal, we have to maintain a kiwi. We have to utilize a kiwi where we'll be inserting the nodes. And third, the return type, we have to observe that how the return type is required. So if you observe the program, here it's list of integer. That means we have to return list. Just notice in the main program that there is list integer. That means we have to return list inside list. So we have to create that type of variable for storing. That means we have to store all the elements in list fashion. In list fashion, we have to create list, and at the end we'll be adding all those lists into a bigger list. So that should be our pattern. So let's start the coding. First we'll be creating the tree. Okay, that let me make you understand the main concept, that how we are gonna solve this problem. Fourth thing, the main important logic is that addition of the nodes. So what we generally do in case of trees, we first just take a kiwi. This is a kiwi. And now when we traverse from left to right, look, we have to traverse once from left to right, and then we have to traverse from right to left, and that's why we will be using a boolean variable right to left, and that's why we will be using a boolean variable that will just revert once again and once again. So we'll be utilizing a boolean variable left to right, boolean left to right, and first time we'll be providing it true. So whenever this is true, we will adding the elements from, as normal we add elements. So how we add the elements? First to insert this 3. We process this 3. So inserted 3. So once when this 3 is here, we check if there is element in the same order. If there are elements, there are no elements in the same order, so we just process 3. So when we pop the elements, we just pop. So this is popped, and this is now then added into another list. This is added into a smaller list. This list now contains 3. Got it? Now we process the 9 and 20. So we added simply the 9 and 20. 9 and 20. These are having, because when we pop this 3, we instantly add this 9 and 20. 9 and 20 is added instantly. So in the second time, when we add this element, now in the second level, we are traversing this level. Right now we are traversing this level. So now we again have to create another list. We'll be again creating another list, but now we will be adding the elements in another section. First we have just added this normally by one. Now we'll be utilizing another function, add first. That means first 9 will be added, and as we are utilizing the add first function, so it will always be adding in the first position. That means when again we'll be inserting this 20, it will add in the first position, that is 20. Now if we observe the traversal order, it becomes like this: 3, it will have 3, then it will have 20 comma 9, then it will have dot 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 as its traverse, like this. The output will be 3, 20 comma 9 and 15 comma 7. So let's implement the entire program in LeetCode, then we'll be better understanding. First we'll be creating the main function. Okay. So first we have to create a node of the tree class. And this is the tree, and this is the tree node data type. So we have to create a node of this class, tree node root. So now we have created a root, and now we'll be creating the tree first. Public So okay, I have created the object. Now after creating object, we have to allocate memory to the root. Solution 1.root, that is equals to new tree node. So now the memory is allocated 3. Now in the left of 3 there is 9. As you can see, this is 9 in the left of 3. So in the left of 3 there is 9. So we'll be adding the left. Solution 1.root.left new tree node 9. So okay. Now in the right there is 20. Solution 1. And in the right there is 20, and right of in the right's left there is right 20, and in its left there is 15. So we'll be adding the 15, right dot left. Seven. So okay, we have added all the elements to the tree. So now our tree is created. So now what, we have to implement the function to get level of the traversal from here. That means we have to call the function from here. So let's call the function, and what will be the return type? This will be the return type. So let's copy it, because we have to store update that type. List result solution 1 dot zigzag. Okay, now we have called the tree. After we have called the tree, second task second task is that we have to create the kiwi. We have to create the kiwi, we have to create the parent list of list. We have to do all those tasks, so we'll be performing all those tasks. So okay, now result, and we'll be storing it like new linked list. So the result list is of type linked list. First things, we check the base condition. If root equals to null, so simply we'll be returning result as null, that is empty. So now this example 3, this empty case is handled by this line, and the number of nodes in the tree is in the range 0 to 2000. So we always have to maintain the constraint. So we have maintained the 0 constraint of this. We have handled this case, we have handled this example 3 number case, that we are returning just an empty node. So after that we have to create the kiwi. So kiwi, and it will be storing tree node data. Kiwi, that is equals to new linked list, and now the queue has been initialized, and we have initialized the queue with respect to linked list. So we can initialize with respect to array list also, but linked list as the best and optimized one. So after that we'll be adding the root to kiwi dot add, we're adding the root. So the queue is not null. Now if the queue is not null, we have to run our program, the entire program one. So we'll be checking if the queue is not null. So kiwi if kiwi dot is empty. So if it is empty, it's returned true, and not empty, that means while this is not empty, then we'll be running the program. So now we start our main code, and now let's understand that we have to implement the main logic. So for that, okay, now we have created the kiwi by now, and we have created this list also, we have created this kiwi also. So what the main things that we maintain this one, this boolean left to right pointer, this is the main things that we maintain in the program, because we'll be utilizing this while adding this. So let's declare this also. Okay, so we'll be declaring this also, boolean left to right, that is equals to true. So now boolean left to right is true. So first we'll be popping the elements, and first how many times we'll be popping the elements, for that we have to need the number of elements. So integer level size, that is equals to kiwi dot size. So this will get us the number of elements in our kiwi, and we'll be popping those elements and we'll be storing those into smaller levels. So linked list, and we'll be storing here the data integer, and let's call it current level. So this is the list of current level where we'll be storing integers, new linked list. Okay, now we'll be popping all the elements one by one. For integer I equals to 0, I less than level size, I plus plus. So now we'll be popping all the elements. First we'll be popping the root node, tree node, current node. So whatever the node we popping, we call it current node. Kiwi dot poll, because kiwi is not having the pop method that is actually present in its stack. So kiwi dot poll, and now we check if left to right, and this is the main thing in here that zigzag fashion starts. We check if that is left to right is enabled, that is if it's true. So we'll be adding the level size current level. We'll be adding the elements current level in normal order. Dot add current node dot val. So we are adding the value, and else if it's not true, so we'll be adding but in the first current level dot add first current node dot val, and this will perfectly handle the cases. So let's understand this again. Okay, so we just implemented this logic now. The first case we handle it normally, just add. We utilized here add method and it add in the normal way 3. And now here we utilize 20 and 9. So 9 and 20 is reverted. First 9 is came here and then 20 comes in front of it. So we implemented this portion, and that is very important portion here. And that gives the zigzag order, that once 320 it comes from this side, then in the next portion it comes from that side, again that, so it comes the zigzag fashion. Okay, so we are again in the coding section. Now we'll be checking if current node dot left, that is not equals to null, that means there is element. So we'll be adding simply those elements to kiwi. So kiwi dot add current node dot left. So whatever the value there is in the left side, we'll be adding that one into kiwi. If current node dot right not equals to null, if right is not null, so we'll be adding in the right side. Kiwi dot add current node dot right. So we added in the right side, and now we will be adding this level. When this loop ends, we have to add this current level. We have to add this current level to the main result array. Result dot add current level. So added this current level, and now we'll be inverting the left to right not equals to left equals to not of left to right. And now the program is finished. We'll be simply returning the return result. So let's run the program. Okay, let's again run. It provided us that we are getting wrong answer, output 3, unexpected 3, 29, 15, 7. So something. Okay, I have actually figured out the mistake we made, that we have actually utilized if, and that's why the loop was running only for once, and it was actually a small mistake. It would be while, and that's why we got the mistake. because we have to traverse for until the queue is entirely empty. So again, if we just run this program, it will compile, and you can see it got accepted.